All right, so this is your lesson on 5.5, which is on solving quadratic equations. Now, some of these problems are going to look very similar to the factoring problems that we did, but the biggest difference between solving a quadratic equation and factoring something is that whenever you're solving, there's going to be an equal sign. Okay? So whenever we factored, we ended up usually with two sets of parentheses, which with a couple of binomials. But with solving, our end result isn't going to be something factored, it's going to be x equals something. Okay? And that was the same thing that we did with linear equations and absolute value equations too. Whenever we solved, we ended up with x equals something. So our equations are going to look something like this. Take a look at this one. We have 2x squared minus 11x plus 15 equals 0. So remember, this really represents a y value. So we're really saying y equals this, and we want to know when that will be equal to 0. So if you think about the graph, when would y be equal to 0? So basically, we're asking when does the graph equal 0? Okay, so what we're really talking about here, when that happens, is actually just the x-intercepts. So whenever we're solving a quadratic equation, that's really what we're looking at. So if you think about that, we could have a graph that maybe looks like this. Okay, now does that have any x-intercepts? Does it ever cross that x-axis? Well, it doesn't, so that would be one that has no solution. Or as we'll see later, actually, those are going to be some imaginary solutions. So I should say no real solutions, I guess. Okay, you could also have something maybe like this, okay, where it just touches that x-axis once. So that would be one real solution. Or you could have something that crosses the x-axis twice. Something like that, two x-intercepts, that would give you two real solutions. Okay, and I just want you guys to keep that in mind. We'll be working with equations, but I want you to think about really what we're talking about graphically. Okay, so we're going to look at three methods today for solving quadratic equations, and the first method is to solve by factoring, and that's going to be exactly what it looks like. The first thing we're going to have to do is factor. Okay, so let's get our factor x. So we're going to need to do 2 times 15 in the top, so that's 30. And then in the bottom, I'll put negative 11. So I need factors of 30 that add to negative 11. So I think I'm going to need a negative and a negative, since that's a negative 11. So if I do negative 6 and negative 5, that'll work. Now we have to watch out because this isn't just an x squared, it's a 2. So I'm going to have to factor 2 out of either the negative 6 or the negative 5. So I have to take that out of the negative 6, since the negative 5 is odd. So if I do 2 times negative 3, that will get me that negative 6. So let's set up our parentheses. Okay, so I know I'm going to have a 2x, and then this will have to be an x right here in order for my first term to be 2x squared. And then I know from my factor x that the 2 has to match up with the negative 3. It has to be multiplied by negative 3 to give me that negative 6. So if I put it here, it's not going to get multiplied by the 2, so the negative 3 has to go here. And then the only thing that's left is our negative 5, or minus 5. Okay, so that's what that equation will look like if it's factored. And remember, it was set equal to 0, so you have to carry that equals 0 through. Okay. So now what we're thinking about is when will this whole equation be 0? Okay, for what values of x? So we could have two things happen. If 2x minus 5 is 0, then it's not going to matter what x minus 3 is, because 0 times anything is always 0. So we could have 2x minus 5 equals 0, and then we can just solve that. So 2x equals 5. So x equals 5 divided by 2. So you can leave that as 5 halves, or that would be 2.5. Or if this x minus 3, if this whole thing is 0, then it's not going to matter what 2x minus 5 is. So I could also have or x minus 3 equals 0. And then if I solve that, I would just get x equals 3. So we end up with two solutions, which means if we would graph it, we would have two x-intercepts. Okay, so our solutions are x equals 2.5 and 3. Okay? So those would be my two solutions. And if you plug those back in there into that equation, you should get 0 for both numbers. Okay? So what we did here was we used the zero product property. Okay? That's what we used actually to set these factors equal to 0. So the zero product property just says that if A times B equals 0, then either A equals 0 or B equals 0. Okay? I only need one of them to be 0, because if 1 is 0, then the whole thing will be 0. So A could be anything if B is 0, and B could be anything if A is 0. Okay, so that's what we're using whenever we're going to set these factors equal to 0. Okay, so let's move this on up. Okay, just a couple things I want you to keep in mind before we start solving these, and as we move forward, is you can see a lot of different names for solutions of quadratic equations. So you might see solutions, you might see the word zeros, or you might be asked to find x-intercepts. Okay, when we talk about quadratic equations, these are all the exact same thing. So if you're asked to find a solution or a zero or an x-intercept, they are all the same thing in terms of a quadratic equation. Okay, and then the last thing I want you to remember before we try some examples, so I have this little thumb reminder here, tied around the finger, is that you always need to set the equation equal to 0 first. Okay, that's very important to remember. And the reason that we need to do that is because we're using this zero product property. So this will only work. I can only set the factors equal to 0 if the whole equation is equal to 0, because the same thing doesn't happen for other numbers. So if I say, like let's say I had this equal to 1, okay, I couldn't just make one of them 1 or the other one be 1. Okay, it's only going to work for 0. So I'm trying to think of a good example. If I had like x minus 3 times x plus 2 equals 1, okay, I can't set those each equal to 1. It's not going to work out that way. So if x minus 3 equals 1, then x would have to equal 4. But then if I want that whole thing to be 1, x plus 2 would also have to be equal to 1. So then x would have to be negative 1. Okay, so then I have two different values for x, which doesn't make sense. They can't be the same thing, or they can't be two different things at the same time. I'm sorry. Okay, so it has to be set equal to 0 in order for us to use that zero product property. Okay, so if you think you've got the hang of it, go ahead and try those first two examples on your own. There's another one actually on the next page if you flip over. If you want to stay with me, then keep it rolling. Okay, so we're going to solve by factoring. So the first one, x squared plus 7x equals 18. First thing I need to do, set it equal to 0. So x squared plus 7x minus 18 equals 0. If I do my factor x, I'll have negative 18 and 7. Oops, sorry. Move that up. Okay, so if I do, let's see, I'm going to need a positive and a negative. So if I do 9 and negative 2, that should work out. So then this will factor to x plus 9. X minus 2 equals 0. And because that is equal to 0, I can go ahead and use my zero product property. So I'm just going to set each factor equal to 0. So I could have x plus 9 equals 0 or x minus 2 equals 0. So then x equals negative 9 or x equals 2. Simple as that. Those are your solutions. Okay, let's look at number 2. So we have 2x squared plus 4x equals 6. That is not equal to 0, so I need to do that first. So 2x squared plus 4x minus 6 equals 0. Okay, and we want to factor, so we always look for a GCF first. And I do have a GCF of 2 here, so I can factor that out. So it'll be 2 times x squared plus 2x minus 3 equals 0. Okay, so then if I do my factor x for the inside, negative 3 and 2. So I need a positive and a negative. So that'll be 3 and minus 1. So we keep the 2 there. So it's 2 times x plus 3, x minus 1 equals 0. Okay? Now, don't be thrown off by that 2 outside. A lot of people say, oh, do I have to set that 2 equal to 0? But 2 will never be equal to 0, so that doesn't really make sense. Okay? So we just care about the x plus 3. That could equal 0, or x minus 1 could equal to 0. Okay, 2 will never equal 0, so it doesn't matter. Okay? So then x equals negative 3, or x equals 1. Okay? If you got those, give yourselves a pat on the back. Very nice job. Okay, one more example we're going to do of solving by factoring. If you want to try it on your own, go ahead. If not, stay with me. Okay, so on the back of your worksheet, here's the first one. So 16x squared equals 8x. Okay, so we need to get that equal to 0. So let's subtract the 8x. So 16x squared minus 8x equals 0. And we want to factor. So it looks like we have a GCF of 8 and also an x. So I can take that out, and I'm left with 2x minus 1. Okay, and that equals 0. Okay, so this is a little bit different than the one before because this isn't just an 8, it's an 8x. So we would want to say 8x equals 0 or 2x minus 1 equals 0. So then if we solve, x could be equal to 0 or 2x equals 1. So x equals 1/2. So those are our two solutions, x equals 0 or x equals 1/2. Yeah. Okay. All right, so some of you might look at that and say, hey, why can't I just divide both sides by x, or even better, divide both sides by 8x? Okay, so let's see what happens if we do that, because I'm guessing that some of you might have tried that, or if you see problems like this, you'll be tempted to try that. So what we want to know is, can we divide both sides by x? Maybe that's another way that we can solve this problem. Oops, sorry, keep moving that paper around. Okay, so let's try that. So we have 16x squared equals 8x. So if I divide both sides by x, let's do that. So we'll get 16x equals 8. And then if I divide both sides by 8, up here we divide by x. Okay, then we're going to get 2x equals 1. So x equals 1/2. So take a look at that. Did we get the same solutions? Okay, we're actually missing one. The problem is we are missing x equals 0. And that happened because we divided both sides by x. So remember, if x is 0, we're never allowed to divide by 0. So because we don't know what the value of a variable is when we're solving, we're never allowed to divide by variables because they could be 0. And if we do, we're going to end up losing that solution of x equals 0. So the answer is no, we cannot divide both sides by x because we will lose a solution, specifically x equals 0. Okay, so not allowed, not allowed, not allowed, cannot divide both sides by x. Okay, I wanted to make sure I showed you why that happens. Okay, so this is the correct solution. Make sure you have both of those. Okay?